QuadQuiz!
Brought to you by Math with Sir Lester. There are 3 questions for this video, and you are to answer them in 15 seconds each. Are you ready? In 3, 2, 1. Consider this given equation. Is this trinomial factorable? Yes or no? The answer is no. Now that we know that it's not factorable, what should be the constant to be added in both sides for the completing the square process? The value we're looking for is 1. To complete the process, what are now the roots of the given quadratic equation? The answer is square root of 6 over 2 plus 1 and negative 6 square root of 2 plus 1. Did you get 3 over 3? If not, please continue viewing this video. This time, this quadratic equation has coefficient of a no longer equal to 1. Here, a is equal to 2, b is equal to negative 4, and c is equal to negative 1. Now these coefficients will be used to determine whether this trinomial is factorable or not, because if it's factorable, then we can automatically use factoring to solve for the roots. If it's not, we proceed with the completing the square method. But then again, there is a quadratic formula which can solve all types of quadratic trinomials. But for this time, we will be using it. So the first thing here is for us to determine whether this is factorable or not using the AC way or the AC method, where we multiply the a and c coefficients. So you have 2 and negative 1. The result for that is negative 2. Now we look for factors of negative 2. And then those factors, pairs of factors, when added, if there is, will result to our b coefficient. And this means this is factorable and because we proceed with factoring. But if it's not, we will do the completing the square method. So the factors of negative 2 could be 1 and negative 2. It could also be negative 1 rather, and positive 2. When you add these pairs, you will not get negative 4. This is an indication that this given trinomial is non-factorable. And hence, without using quadratic formula, in solving for the roots, we are going to use the completing the square method. The completing the square method is an assurance as well that your roots later on will contain radical expressions. There are roots, okay, in our results later. So we are going to complete the square, meaning we are going to remove the constant negative 1. So you have here 2x squared minus 4x minus 1 equal to 0. We're going to remove this negative 1 here because that's not the constant we need. So we will have here 2x squared minus 4x, and your right hand side will be positive 1. Before we could proceed with finding the appropriate constant that will make this left hand side perfect square trinomial, we need to divide all terms here by 2. Why 2? Because our coefficient of a here is 2. If it's 3, then we divide it by 3. If it's 5, we divide it by 5. So you will have here x squared minus 2x is equal to 1/2. The reason, of course, for dividing all terms by the coefficient of a is so that our solution for the constant, I'm labeling it c sub 1 so as not to be confused with the original c. This is now the constant that we really need in order for this side to be a perfect square trinomial. If it's a perfect square trinomial, then we could proceed with appropriate processes later. The formula for solving the appropriate C is b over 2, and usually we forget this, and it's okay to forget that if our a is equal to 1, but I'm just writing square root of a before we take the square, because generally it should be square root of a. So this means that the appropriate C to be used here, take out our b is negative 2, not this b here, okay? The b of this new form after you divide all terms by 2. So you have negative 2, divide by 2, square root of a, which is 1, and you take the square of it. You will get a result of negative 1 squared, which means the appropriate C is equal to 1. This is now the appropriate constant we'll be adding here. So you have x squared minus 2x. You add 1 here so that this would become a perfect square trinomial. But don't forget to do the same thing on the other side. So you have 1/2 plus 1. The next part here is we can express this perfect square trinomial as a square of a binomial. We do that so that we could apply extracting square roots later. We actually have the square of the binomial using the square root of the first term, x squared, that's x. The square root of the last term, 1, is 1. And we use the sign of the middle term, minus. If you're not convinced with this, of course you could always try to verify this by multiplying two binomials of x minus 1. And this is equal to 3/2 on your other side. That's 1/2 plus 1, which is 2/2. Here, let's take the square root of both sides now. Take note that when you do that, plus minus here for a constant. So you have, we'll have here x minus 1 would be equal to the positive, negative. We could separate this square root of 3 over square root of 2. The reason for this separating these two is actually we need to rationalize the denominator. Okay, we need to rationalize this so that our denominator will not contain any radical expression. So we multiply square root of 2 and square root of 2, which is just equal to 1, therefore not changing the value of the entire equation. We also use square root of 2 so that the denominator will become square root of 4, and square root of 4 is just equal to positive 2. So we have here positive, negative, square root of 3 times square root of 2 becomes square root of 6. This is also why I am a firm believer that the quadratic equation topics should be discussed right after radical expressions, because you need to understand how to simplify radical expressions, how to rationalize denominators involving radical expressions before you understand the completing the square method as well as the quadratic formula I have mentioned earlier. Over square root of 4, which is 2. Now that we have this, we add both sides by 1. So you will get the expression plus minus square root of 6 over 2 plus 1. So we could have two roots here. Our first root is where we use the positive square root of 6 over 2 plus 1. And our second root is the negative square root of 6 over 2 plus 1 as well. So they only differ with the sign of the radical expression. Of course, you can still combine this and you will have the other form. For those who would like to have one rational expression, you have square root of 1 over 2 all over 2. Why this is 2? Because that's 2 over 2 when you add them up. But I'm just going to stick with this so that it would be confusing for a sum. This is now the solution for the roots of this given equation using completing the square method, because in the first place it's not factorable. And this is for this QuadQuiz. Subscribe now.